As I look over this integral and think of how I might integrate this, I see that I have this radical here, and I'm looking at possibly then a trig substitution. I would want to draw a triangle so that this was one of the sides. So I'm going to make a right triangle, and I'm going to label the hypotenuse 3 and this side x. That way, doing a Pythagorean theorem, this side would be 9 minus x squared. And let's put theta here. The trig function relating those two easier sides is sine theta equals x opposite over hypotenuse 3. Solving this for x, I have x equal 3 sine theta, and that means dx is 3 cosine theta d theta. We're ready to do our substitution then. I've got the square root of 9 minus x squared, so that's going to be 9 sine squared theta over x squared, which was 9 sine squared theta, and then dx, which is 3 cosine theta d theta. Let's see what we could do to simplify this. So we can factor out a 9 in the numerator and leave us 1 minus sine squared theta. And then we could change that to a cosine squared theta, and then we still have that over 9 sine squared theta and our 3 cos theta d theta. Let's go ahead and square root here, so that will leave me the integral of 3. We have cosine theta when we square root, but multiplied by a cosine theta here, so that's cosine squared theta, and this 3 will actually become a 9 because we multiplied the two 3's together, and that's over 9 sine squared theta and d theta. Now the 9's will cancel, and we know that cosine theta over sine theta is cotangent, so this is cotangent squared theta d theta. Now thinking of an antiderivative, do I know an antiderivative for cotangent squared theta? And I don't, but I can use a Pythagorean identity, and I can express as cosecant squared theta minus 1, and that's helpful because I do know an antiderivative of cosecant squared theta. So the antiderivative of cosecant squared theta is going to be negative cotangent theta. The antiderivative of negative 1 is going to be negative theta plus a constant. Now the last thing we have to do is get this back in terms of x, and we use our triangle to do that. So we have negative, I need cotangent theta. Cotangent is adjacent over opposite, so that's going to be the square root of 9 minus x squared over x minus, now I need theta. How am I going to get theta? Well, I'm going to take this equation right here and take the inverse sine of both sides. That will tell me theta is sine inverse of x over 3. So I can put that substitute for my theta. That's going to be sine inverse x over 3 plus a constant.